Hello students, let us continue the session on rational numbers. In the previous session, I had asked you to solve this question: if 7 by m is equal to 49 by 63, find the value of m. Hopefully you must have done that. The value of m is 9. Those who have not got the answer, please look into the answer here. 7 by m given equal to 49 by 63. If you do cross multiplication, that is numerator of the first rational number multiplied to denominator of the next rational number, we get 7 times of 63. The denominator of the first rational number multiplied to numerator of the next rational number, we get m times of 49. So the value of m is 7 times of 63 divided by 49. What I have done is I have divided both sides of this equation by 49. So 7 times is 49, 9 times is 63. So m value is 9. This is one of the method. Another method is look at this equation 7 by m is equal to 49 by 63. On multiplying 7 to both numerator and the denominator, I'll be getting 49 in the numerator. 7 times is 49. So what we have is 7m equal to 63. Therefore, the value of m must be 9. Then only it becomes 63. This is another method. Let us solve another question. Fill in the blank. Minus 7 upon 15 equal to blank upon 135. In this blank, suppose if I consider this as x, if I use the previous method, 15 times x will be equal to minus 7 times 135. So x value will be minus 7 times 135 divided by 15. Let us simplify this. We can divide by 5. 5 3 times is 15. 5 2 times is 10. 5 7 times is 35. 3 9 times is 27. So minus 7 multiplied to 9 will be negative 63. So the value of x is negative 63. The next concept is comparison of rational numbers. Here is a question: which of the two rational numbers 3 by 5 and negative 2 by 3 is greater? You all must know that always positive number will be larger than a negative number. So it's very clear that 3 by 5 is a positive rational number. This has to be greater than negative 2 by 3. 0 is always greater than any negative rational number. Now look at the question. Both the rational numbers given are negative because it's 3 by negative 4 and negative 5 by 6. Now how do we check whether the given rational number is larger or smaller? For doing that, we can express the denominator as a common denominator. So for that, I am going to find the LCM of 4 and 6. The LCM of 4 and 6 is 12. That is because when 4 and 6 we find the LCM, it is 2 2 times, 2 3 times, 2 1 time, 3 1 time. Therefore, LCM will be the product 2 into 2 into 3, which is 12. Now, after finding the LCM, we'll express the given rational numbers with the common denominator. So I need to multiply 3 so that the denominator becomes 4 times of 3, which is 12. So this minus I'll write here. So it is negative 9 upon 12. Minus 5 by 6. Now I'll multiply with 2 so that the denominator will be 12 and numerator becomes negative 10. Now it's very easy to compare these two rational numbers. Since they have got the common denominator, I can compare the numerators. So clearly negative 9 upon 12 is larger compared to negative 10 upon 12. Therefore, we have negative 3 by 4 greater than negative 5 by 6. This is how we compare rational numbers. Once we learn this comparison, it becomes easy for us to arrange the rational numbers in a ascending order or a descending order. There is another method to compare rational numbers, that is by multiplying numerator of the first rational number with the denominator of the next rational number and comparing it with the product of denominator of the first rational number multiplied to the numerator of the next rational number. We shall see that. Now let us compare these two rational numbers, 5 upon 7 and 3 upon 5. So what I do is, I will multiply the numerator of the first rational number with the denominator of the next. Then I'll multiply denominator of the first rational number with the numerator of the next. So what I get is 25, and here I get 21. It's very clear that 25 is larger compared to 21. I can say that 5 upon 7 is larger than 3 upon 5. Now we shall express the given rational numbers in ascending order. For that, I will rewrite the given set of rational numbers in this way: negative 7 by 10, negative 5 by 8, and negative 2 by 3. Now I require the least common multiple of the denominators 10, 8, and 3. To find that, I'll follow prime factorization method. Let me divide by 2 to 5 times, to 4 times. 3 is written as it is. Once again, I can divide this by 2. Now all these are prime numbers, so the LCM will be nothing but 2 multiplied to 2 multiplied to 5 multiplied to 2 multiplied to 3. 2 multiplied to 2 is 4. 4 times of 5 is 20. 20 times of 2 is 40. 40 times of 3 is 120. So I get 120. Let me express negative 7 upon 10 with the denominator as 120. For that, I'll multiply 10 with 12. Hence, the numerator also I'll multiply with 12. I get negative 84 upon 120. For the next rational number, it's minus 5 upon 8. This 8 has to be multiplied by 15. So minus 5 should be multiplied with 15. We get it as negative 75 upon 120. Same time, I'll express this minus 2 by 3 with the denominator 120. So 3 to be multiplied by 40. So minus 2 has to be multiplied by 40. I get negative 80 upon 120. Now you compare these three rational numbers which are having 120, in the denominator. Clearly, we have negative 84 upon 120 as the smallest one, and the next larger is negative 80 upon 120, and the next larger is negative 75 upon 120. Now I will replace these rationals with the corresponding rational numbers. Minus 7 upon 10 is the least, followed by minus 2 by 3, followed by minus 5 by 8. This is how we arrange the rational numbers in ascending order. We shall solve one more question. Here there are 4 different rational numbers given. First, let me express the given rational numbers. 5 by 8, minus 5 by 6, minus 7 by 4, 3 by 5. Now all the denominators are positive. Let me find out the least common multiple of LCM of 8, 6, 4 and 5. Let me follow prime factorization method. I'll start dividing by the least prime number 2 4 times, 2 3 times, 2 times, 5 is written as it is. Now I divide by 2 times, 3, 1, 5. Therefore, the LCM is the product 2 into 2 into 2 multiplied to 3 into 5. So we get the product as 120. Let me now express each one of these as a common denominator. Now 8 has to be multiplied by 15. So the numerator to be multiplied by 15. 15 5 times is 75. So 75 divided by 120. Now 6 has to be multiplied by 20. Hence minus 5 to be multiplied by 20. We get it as negative 100 upon 120. Now 4 to be multiplied by 30. Hence negative 7 to be multiplied by 30. We get it as negative 210 upon 120. Now 3 by 5. 5 to be multiplied by 24. So 3 to be multiplied by 24. When 3 is multiplied by 24, we get it as 72 divided by 120. Now we can compare the numerators. The smaller numerator is negative 210 by 120, which is smaller compared to negative 100 divided by 120, which is smaller compared to 72 divided by 120, in turn smaller than 75 by 120. Now I'll replace with the original rational number. Minus 210 by 120 is same as negative 7 by 4, which is smaller compared to negative 5 by 6, which is smaller compared to 3 by 5, which is smaller compared to 5 by 8. Hence, this particular form is the ascending form or ascending order. Let us solve few more questions wherein we use descending order. To do that, first let me express all the denominators of the given rational numbers as positive 1. These will be the rational numbers. Let's find the LCM of 5, 10 and 8. 5, 10 and 8. Divide by 2. 2 5 times, 2 4 times. Further divide by 2. Now divide by 5. Now the LCM is 2 multiplied to 2 multiplied to 5 multiplied to 2, which is 40. So negative 3 by 5, negative 7 by 10, negative 5 by 8. These rational numbers I'll express as the common denominator. What should be multiplied to 5 so that we get 40 in the denominator? It has to be 8. So minus 3 multiplied to 8 is negative 24 by 40. 10 to be multiplied by 4. So we get negative 28 upon 40. 8 to be multiplied by 5. So we get negative 25 upon 40. Now it is a descending order, so I have to start from the larger number. Here, out of these three numerators, negative 24 is the largest. So negative 24 by 40 is larger compared to negative 25 by 40, which is larger compared to negative 28 by 40. Now I'll replace with the original rational numbers. This is negative 3 by 5 larger than negative 5 by 8 larger than negative 7 by 10. Next question is to arrange in descending order. They have given 4 different rational numbers. Out of these 4 different rational numbers, look at them, 2 of them are positive. 4 by 9 and minus 7 by 12, they are positive. So not to have confusion, let's rewrite with the denominators as positive and then find the least common multiple of the denominators. So let me find the LCM of 9, 6, 12 and 24. Let us follow prime factorization method. 9, 6, 12, 24. We need to divide by the least prime number 2. 9 is written as it is, 2 3 times, 2 4 times, 2 12 times. Further I divide by 2 2 times, 2 6 times. Once again I'll divide by 2 1 time, 2 3 times. Now consider 3 times, 1 1 1. 3 1 time. Now the LCM is 2 multiplied 3 times into 3 multiplied 2 times, which is 8 times of 9, 72. So 4 by 9, I have to express denominator as 72. So 9 to be multiplied by 8. So 4 is multiplied by 8. We get 32 upon 72. Negative 5 by 6. 6 has to be multiplied by 12. So minus 5 to be multiplied by 12. We get negative 60 upon 72. 7 by 12. 12 to be multiplied by 6. Hence 7 to be multiplied by 6. We get 42 divided by 72. 11 upon 24. This 24 is to be multiplied by 3. So 11 to be multiplied by 3. We get 33 by 72. Therefore, the descending order will be start with the highest numerator. Here the larger numerator is. So here I made a mistake. This is negative 11. So this is negative 33. To write in ascending order, let me order them. This will be the largest. So it has to be first. This has to be second. This has to be third. And this has to be fourth. Therefore, 7 by 12 is larger compared to 4 by 9, which is larger compared to negative 11 by 24, which is larger compared to negative 5 by 6. This is the ascending order. In class 6th, we have learned to represent whole numbers, and in class 7th, we have learned to represent fraction on the number line. I want you to recall how to represent the fractions on the number line so that in the next session, we shall represent the rational numbers on the number line. That's all for today's session. Thank you.